Hello, everyone, and welcome back to another math session with, of course, yours truly, Damian Anderson and Andrew Frett. So we are entering our seventh week, and this is day 12. And as you can see, you guys, we have been doing this for quite some time. We just been out, I think, probably 2 or 1 day of missing this, but we are back because our schedules are busy. But we are back to helping you guys improve your math scores. So we are back, and today actually is, as you guys already know, the sixth graders, that today is Andrew's last day before he goes off on vacation. But you guys, he'll be back. Not next week, but the week after next, October 26th. So he will not be here at all next week. It's just going to be me. So sixth graders, you also pay attention to my lesson as well. Since Andrew's not going to be here, you still pay attention to my lesson. So, Andrew, you have
Absolutely.
something to say to your sixth graders?
Um, yeah. So again, I'll be gone for 2 weeks. Taking my vacation. Um, please take notes. I don't want to be that teacher. You're not that teacher. Don't be bad when the sub gone. When I'm not here. Okay. Um, so for my sixth graders, go ahead and tell you now. Damien is just like me. Okay. So I like he's just like me. So if you act up or if you did not take notes or if you did not take a picture or whatever, he, it's on you. But please pay attention to his lesson, write some down. Um,
Mm-hmm.
I will because once I return back, I'm gonna do a recap, kind of like a lesson rewind, which is new. I'm gonna do a lesson rewind, kind of like review everything that we learned before I left, and then we're gonna go into the new lesson. So make sure you pay attention. But
Mm-hmm.
like I said, like Damien said, I'll be back on October 26th, which is 2 weeks from Monday. Not next week, but the following week, almost the end of October.
Yeah.
So
So, you guys, again, please pay attention and you have your notes out and taken them because this is why we are doing this, you guys. We came up with this idea to help you guys improve in your math class. That is why we are doing this. This is like a head start to us once we enter into the classroom because we will know how we are going to be teaching because we're doing it here virtually, of course. So that is why we are doing this in the first place to help you guys improve your math scores because we want those scores to be higher, 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 higher. So um, that's all I have to say there before we begin our session is just please pay attention. And also, if you have some of your friends who are also struggling with math, please let them know that the co-hosts, two of the co-hosts of Future Educators Talk are doing math virtual learning session each week. And they are
Monday and
uploaded,
Friday.
yes, Monday and Friday. We do it at the exact same, we record at the exact same time and we upload them onto our YouTube channel the very next day. So
The next day.
yes. So if you guys, if you know someone who is struggling, please let them know that we are doing this to help the sixth graders and the eighth graders out. Not just only them, but to any grade level who is struggling with math. We will also help you guys
Mhm.
as well. But I just, I don't know. I just don't know at this point. If you guys are still struggling and you can't, you can't find no help, because we are trying our best to help you guys, and if that's still not helping, then I don't know what to tell you. Because first of all, you're probably not taking notes correctly. You're not listening to what we are saying. You think we're just talking, and we're just not saying anything important, which we are. But
We are.
yeah,
Our mouths are moving. But
yeah, yeah.
it's your choice. If you don't want to take notes, if you don't want to be, if you want to not get a 3 on your EOC, or or on your integrate tests, that's fine.
Yeah.
But
Mm-hmm.
let's hop right into
Mm,
this
yes.
lesson today.
Yes, shall
Because
we?
I'm pretty sure this this day is brand new for both of us. You have a brand new. I like how I'm pointing up. Well, the video is going to point this way.
Yeah.
Um, you have a brand new lesson to talk about, as well as I'm reviewing and a brand new lesson. So
Yeah.
let's start it.
All right. So I guess we're gonna start with me first. So let's, my eighth graders. Long time no see, you guys. Last time that we was together was we reviewed rational and irrational numbers. Um, and that was a fun lesson, of course. I love doing those because, like I mentioned in one of those sessions, that it is an easy lesson to teach. I believe it's an easy lesson to teach. It's so simple. It can't get any more complicated. Okay. I'm gonna say this again. Rational numbers, you guys. If you did not copy this down, please copy it down now. This is the last time that I'm going to say it until at the end of the school year when I review everything. So if you did not copy this down during the session that I talk about rational and irrational numbers, please copy it down now. Rational numbers can be written as a fraction. Okay, so write that down. Then you have irrational numbers. It cannot be represented by a fraction. It cannot be written as a fraction, you guys. And also, you guys, I gave you some examples of rational numbers and irrational numbers, also with whole numbers and integers. So, which I did on the last session. So make sure you guys check that out. But that's the last time I'm going to mention that again until the end of the school year when I review everything. But today, you guys, I have a new lesson. So let's move past on rational and irrational numbers, and let's go into the new lesson, which is scientific notation. Yes. So today I'm going to be introducing you guys to rational, right? Oh my God. See, my mind is still focused on rational, irrational numbers. I'm going to be showing you guys an introduction to scientific notation, and then I have a video which is 28, I believe 28 minutes long, explaining scientific notation. But first, I have some notes for you guys to copy down before I show you the video. So let's get started with scientific notation. And hopefully, you guys, you can see the screen. All right, let me make sure. Andrew, can you see this here?
Yes.
Okay, perfect. Now, let's get started, you guys. Scientific notation. Now, first, you see, you guys, that I have um, some important key information, some key facts. And Andrew, he did this like a couple weeks back when he was doing one of his lessons of some key facts and info. Now, you guys, you will use this for scientific notation. Now, this is for word problems, which I will get into in two more days, in about 2 more weeks, 1 more week, I believe. But anyways, you will use this in word problems. When you see this, for example, we got add, multiply, subtract, and divide. Now for add, in word problems, you need to focus on if it says total or how many, how much, or sum, that means you will add. Okay, so make sure you copy this down. Whenever you see this in a word problem for scientific notation, you're going to add. Now, when we go to subtract, you will use, when you see how much more, and I don't know why I got this down twice, how much more. This is supposed to be something else here. I will see what this is supposed to be here, you guys. But when you see how much more or difference, that means you're going to subtract. Okay. Then if you see for, again, we got total, how many or how much, and then the product, you should also know product is to multiply. Then we come down here where we have divide, how many times per, and in quotient, you're going to divide. So copy this down now. Underline it in word problems. If you see how much more in a word problem, underline it and know that it means you're going to subtract. For divide, if you see per, you should also know that's for divide. When you see product, you should know that will be multiply. When you see sum, you should know that is addition. So copy this down, copy this down. I'm gonna give you guys some time to copy this down, take a screenshot of this, or just quickly copy this down. And then we are going to continue moving on with scientific notation. And also sixth graders, copy this down as well. Copy this down as well, because you will see this, trust me, you will see this. Andrew, he will agree on me with this. You will see this, sixth graders. So copy this down, please, please.
Yes, copy this down because I will explain this in upcoming weeks. Okay.
Yes.
Also, you should already know this table
Yeah.
because I talked about it a couple
Yeah.
weeks ago.
Yeah.
So that's why I told you it's very important to write this down because you never know when our lessons intertwine. I told you many times, this is the part where our lessons intertwine with each other. And you will see that again today. So make sure you copy this down.
Yes. All right, you guys. Now, I gave you some time to copy this down. If not, I'm moving on. So let's move on to more notes. And look what we have here, scientific notation. I believe all this is on here. Scientific notation. Now, okay, let's focus on right here, you guys. This is what is, let me zoom in on this here. Okay, so you guys see here, this is what a scientific notation looks like here. It's almost like sort of kind of an equation, if you could say. But this is what a scientific notation looks like. And here's the example I have here, 6.2 times 10 to the 9th power. And you guys should know what this quite represents here. My 8th graders, you should quite know what this represents here. I'm not going to say it because you guys should know. But as you can see over here, 6.2, I got this in box because this is a coefficient. Copy this down. This is what this is. Whatever is right here in this place, that's your coefficient. And then you see I have to the ninth power circle, and that is the power of 10. So whatever number is right here, that is the power of 10, because you guys right here, this is always going to be 10 here. This right here. It's not going to be any other number. It's not going to be 1. It's not going to be 2. It's not going to be 5. It's not going to be 60, 100. It is always going to be 10, not any other number with scientific notation. Then I have underneath here, I just rewrote again, but I did 10 to the negative ninth power. And of course, you could do negatives with scientific notation, which I will dive deep into that with next week's lesson, or probably today, actually. Now, let's move on to over here where I have standard notation. Now, this is what a standard notation looks like. You have numbers here. And this is 6,200,000. This is an example of standard notation. And then you're going to transfer this into this lovely number right here. And you have 1, 2, 3, 4, 5, 6, 7, 8. You have 8 zeros down here. And then you're going to put whatever numbers are between these two here at the end. Okay. So you're just transferring this into this here. You see up here, we got 8 zeros. So you put 8 zeros down here. And then you would copy down these two numbers into down here. So yeah. Now, let's move on to multiplication. Well, multiply and divide, which I will get into in next week's lesson of multiplying and dividing scientific notation, and also adding and subtracting scientific notation. So as you can see down here, we have, and you can always do parentheses with these, always parentheses. And you know, between here, you guys can put a times, you know, the multiplication symbol right here in between here, or you could put a circle here, which that means multiplication. But what I do is just put, you know, close the parentheses here and then open parentheses right here, because I know that between here, you are going to multiply. I know that. So whichever is easier for you, you do it. Now, we have 2.1 times 10 to the second power times 3.4 times 10 to the 2.5 power. Now, actually, as you can see here, we have 1. You're going to multiply the coefficient. These are your coefficients that are underlined purple. So you're going to multiply the coefficients, which we have here 2.1 times 3.4, okay? And then the second we have is you're going to add the exponents, what I have circled in red, which is 2 and 2.5. Now, and then our answers are going to get this here. 2.1 times 3.4 gives me 7.14 times 10. You're going to bring down that 10 because you're going to use that every time. It's not going to be any other number. Times, then you're going to add your exponents. 2 plus 2.5 is 37. So that is your answer. So I'm going to have you guys time to copy that down. And then we're going to move on to division.
You said
Yes,
add, right?
correct.
2 times 2.5, correct?
2 plus 2.5. I believe that's a 2 right there. What does that give me?
Give me 1 second. That is going to give you, sir, 4.5 if you add them together.
Okay. Oh,
But
apparently I
if
can't.
you times them together, it'll be 5.
Okay. Apparently, you guys, I cannot read my own handwriting here, but that is incorrect there. And that is supposed to be another number there. So I will let you guys know what that number is. So just
Ooh.
mark that out, and then I will give you guys the correct answer in next week's lesson. At the beginning of next week's lesson.
So it will be 14.8 if you times them together.
That's just a wrong number I put there because you're supposed to add the exponents when you are multiplying scientific notation. You're supposed to add the exponents. So that is not supposed to be a 2 right there. That is supposed to be another number. And I will have to fix that. So I will let you guys know what that number is at the beginning of next week's lesson. So don't I don't want to use Andrew's catchphrase, but don't fret about it. I will let you guys know next week.
Uh,
Okay, so moving on, let's go to division, you guys, and hopefully I got the correct numbers here. So with division, here's how, because with division, you could set it up as a fraction form, which means you know that you're going to divide. So the first number we have is 3.6 times 10 to the negative 11th power. That is 11 right there, you guys. I know that's 11. Then you have 1.2 times 10 to the 24th power. Now, again, with this, what I have in underlined purple, you are going to divide the coefficients because we are dividing. We're not going to add, we're not going to subtract, we're not going to multiply, we're going to divide. You're going to divide 3.6 into 1.2, and that gives me 3.0 times 10. Then the second is you're going to subtract the exponents, which I have negative 11 minus, that's not 24, you guys, that's 2.4. I'm looking at my notes now. That's 2.4, not 24. Put a dot between 2 and a 4. That's 2.4, not 24, you guys. And let me, hopefully this gets me, let me check my math real quick. Let me check it. And hopefully this gets me. No, it doesn't. Hold on, you guys, very quickly. Okay. Okay, you guys ignore this here, the multiplication and the division, because I am, for some reason, I am using some incorrect notes that I have here. So you guys, I would do this at the beginning of next week's lesson and give you guys another example of this here with some different numbers. How about that? But don't worry about this here. Don't copy it down. Don't copy it down. Let's move on to down here. Now, this is what you're going to do with scientific notation. Now, the negative exponents, you're going to move the decimal point to the left every single time. And with the negative exponents, you're going to, and you see I have it highlighted, which means you should highlight it as well. You're going to divide by 10 each time with a negative exponent in scientific notation. Then we have positive exponents. And it is the same category, except you're going to move the decimal point to the right, and you're going to multiply by 10 each time. So with a negative exponent, you're going to move the decimal point to the left, and you're going to divide by 10 each time. And then with a positive exponent, you are going to move the decimal point to the right, and you're going to multiply by 10 each time. So copy this down here, you guys. Copy these two down here, and then copy this here, these two sections. Don't worry about the multiplication division. I'll have to fix that. So just copy down these two here, you guys. Let me, to where you guys can be able to see this all. So just worry about this section here, and then the bottom two. Don't worry about this here. Give you guys time to copy it down. Okay, now let me stop the share really quickly, and then we're going to move into, I'm going to show you guys another video. Well, another video. I'm going to show you guys a video of scientific notation. And this is the introduction to it, which is 20 minutes long. I said 28 minutes, but it is 20 minutes long. So let me pull it up. And of course, pay attention. All right, let me pull it up. All right, here we go. Pay attention and copy notes. Copy, write notes. Here we go.
I don't think it's any secret that if one were to do any kind of science, they're going to be dealing with a lot of numbers. It doesn't matter whether you do biology or chemistry.
Hopefully you
or
guys can
physics.
hear that.
Numbers
That's
are
quite
involved,
low.
and in many cases, the numbers are very large. They are very, very large numbers. Very large numbers, or they're very small numbers. Very small numbers. You could imagine some very large numbers. If I were to ask you how many atoms are there in the human body, or how many cells there are in the human body, or the mass of the Earth in kilograms, those are very large numbers. If I were to ask you the mass of an electron, that would be a very, very small number. So in any kind of science, you're going to be dealing with these. And just as an example, let me show you one of the most common numbers you're going to see, and especially chemistry. It's called Avogadro's number. Avogadro's number. And if I were to write it in just the standard way of writing a number, it would literally be written as, do a new color, it would be 6022, and then another 20 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19,
Now
20.
you guys do not have to do this here. I do not want you guys to do this here. Just listen to what he has to say here.
And even if I were to throw some commas in here, it's not going to really help the situation to make it more readable. So let me throw some commas in here. This is still a huge number, and I don't even, if I had to write this on a piece of paper, or if I were to publish some paper on, using Avogadro's number, it would take me forever to write this, and even more, it's hard to
Exactly,
tell if I forgot to
exactly.
write a 0, or if I maybe wrote too many zeros. So there's a problem here. Is there a better way to write this?
Yes, there
So is
is.
there a better way to write this than to write it all out like this, to write literally the 6 followed by the 23 digits, or the 6022 followed by the 20 zeros there. And to answer that question, and in case you're curious, Avogadro's number, if you had 12 grams of carbon, especially 12 grams of carbon-12, this is how many atoms you would have in that. And just so you know, 12 grams is like a 50th of a pound. So that just gives you an idea of how many atoms are laying around at any point in time. This is a huge number. But that's the point of here isn't to teach you some chemistry. The point of here is to talk about an easier way to write this. And the easier way to write this we call scientific notation.
Yes.
Scientific notation. And take my word for it, although it might be a little unnatural for you at this video, it really is an easier way to write things like that. So before I show you how to do it, let me show you the underlying theory behind scientific notation. If I were to tell you what is 10 to the 0 power, we know that's equal to 1.
Exactly.
What is 10 to the 1 power? That's equal to 10. What's 10 squared? That's 10 times 10. That's 100. What is 10 to the third? 10 to the third is 10 times 10 times 10, which is equal to 1,000. I think you see a
Square
general
roots and
pattern
cube
here.
roots.
10 to the 0 has no zeros. No zeros in it, right? 10 to the 1 has 1 0. 10 to the 10 to the second power, I was going to say the 2th power, 10 to the second power has 2 zeros. Finally, 10 to the third has 3 zeros. Don't want to beat a dead horse here, but I think you get the idea. 3 zeros. If I were to do 10 to the 100th power, 10 to the 100th power, what would that look like? I don't feel like writing it all out here, but it would be 1 followed by, you could guess it, 100 zeros. So it would just be a bunch of zeros. And if we were to count up all of those zeros, you would have 100 zeros right there. And actually, this might be interesting, just as an aside. You may or may not know what this number is called. This is called a googol. A googol. In the early 90s, if someone said, "Hey, that's a that's a
very
googol,"
interesting.
you wouldn't have thought of a search engine. You would have thought of the number 10 to the 100th power, which is a huge number. If you actually, it's more than the number of atoms, or the estimated number of atoms in the known universe. In the known universe. I mean, this is a question of what else is it there out there. But I was reading up on this not too long ago, and if I remember correctly, the known universe has the order of 10 to the 79th to 10 to the 81 atoms. And this is, of course, rough. No one can really count this. People are just kind of estimating it, or even better, guesstimating it. But this is a huge number. But maybe even more interesting to you is this number was the motivation behind naming a very popular search engine, Google. Google. Google is essentially just a misspelling of the word Google with the O-L. And I don't know why they called it Google. Maybe they got the domain name. Maybe they want to hold this much information, maybe that many bytes of information, or it's just a cool word. Whatever it is, maybe it was, the founder's favorite number, but it's a cool thing to know. But anyway, I'm digressing. This is a Google. It's just 1 with 100 zeros. But I could equivalently have just written that as 10 to 100, which is, clearly an easier way. This is an easier way to write this. This is easier. In fact, this is so hard to write that I didn't even take the trouble to write it. It would have taken me forever. This was just 20 zeros right here. 100 zeros I would have filled up, and I would have filled up this screen, and you would have found it boring. So I didn't even write it. So clearly, this is easier to write. And so you might beg, well, how can we write? This is just good for powers of 10, right? But how can we write something that isn't a direct power of 10, how can we use the power of this simplicity? How can we use the power of this simplicity somehow? And to do that, you just need to make the realization. This number, we could write it as, so this has how many digits in it? It has 1, 2, 3, and then 20 zeros. So it has 23 digits after the 6, right? 23 digits after the 6. So what happens if I use this, if I try to get close to it with the power of 10? So what if I were to say 10 to the 23, do it in this magenta? 10 to the 23rd power, that's equal to what? That equals 1 with 23 zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. You get the idea. That's 10 to the 23rd. Now, can we somehow write this guy as some multiple of this guy? Well, we can, because if we multiply this guy by 6, so what is 6? If we multiply 6 times 10 to the 23rd, what do we get? Well, we're just going to have a 6 with 23 zeros. We're going to have a 6, and then you're going to have 23 zeros. Let me write that. You're going to have 23 zeros like that. Because all I did, if you take 6 times this, you know how to multiply. You'd have a 6 times this 1, then you get a 6, and then all the 6 times the zeros will all be zeros. So you'll have 6 followed by 23 zeros. So that's pretty useful, but still we're not getting quite to this number. I mean, this had some 2's in there, so how can we do it a little bit better? Well, what if we wrote it as a decimal? This number right here, is identical to this number as if these 2's were zeros. But if we want to put those 2's there, what can we do? Well, we could put some decimals here. We could say that this is the same thing as 6.022 times 10 to the 23rd. And now this number is identical to this number, but it's a much easier way to write it. And you could verify it if you like. It'll take you a long time. Maybe we should do it with a smaller number first. But if you multiply 6.022 times 10 to the 23rd, and you write it all out, you will get this number right there. You will get Avogadro's number. Avogadro's number. And although this is complicated, or it looks a little bit unintuitive to you at first, this was just a number written out. This has a multiplication and then a 10 to a power. You might say, hey, that's not so simple. But it really is, because you immediately know how many zeros there are. And it's obviously a much shorter way to write this number. Let's do a couple of more. I started with Avogadro's number because it really shows you the need for a scientific notation, so you don't have to write things like that over and over again. So let's do a couple of other numbers, and we'll just write them in scientific notation. So let's say I have the number 7,345, and I want to
Okay,
write it as
let me stop here because that, and I don't know why I let it go in for 9 minutes, but that is that was not what I had in mind. I'm so sorry, you guys. Today I'm just all over the place. So let me just find like a short explanation of this. And then hopefully next week I'll be back to myself. So you guys just talk among yourself while I try to let me stop share and let me find what I am looking for, because that was not it. So y'all just hold on for just a second. Okay, let's do this here. Don't you guys just love ads on YouTube? Okay. And this is just 14 minutes long. So you guys, you could handle this here. Okay. Yep. Okay. This is what I'm looking for. Okay. Let me share my screen again. And let's watch it together. Okay, here we go.
Hi, I'm Rob. Welcome to Math Antics. Have you ever heard people use numbers like that? 1 times 10 to the 6th, or maybe 3.4 times 10 to the negative 8th? Well, those are
And copy these examples and problems down in your notes.
examples of a way of writing numbers called scientific notation. Huh, that didn't sound quite right. Let me try that again. Scientific notation. Ah, yes, that's better. Numbers can be really big or really small, right? Like if you wanted to count up.
No. Really? Don't you guys just love technology? Wow. Okay. Is that how you're going to do on me?
Scientific notation. Ah, yes, that's better. Numbers can be really big or really small, right? Like if you wanted to count up.
Oh, no.
Scientific notation. Huh, that didn't sound quite right.
If this
Let me try that
then
again.
I'm going to stop it.
Scientific notation. Ah, yes, that's better. Numbers can be really big or really small, right? Like if you wanted to count up all of the cells that make up your body, it would be a really big number, something like 35 trillion cells. But if you wanted to measure the diameter of one of those cells using meters, you'd get a really small number, something like 0.0000005 meters. Not only are really big or small numbers a lot of work to write down because of all the zeros, they're hard to quickly evaluate and compare. At a glance, it's not easy to tell just how many number places there are in these really big or small numbers. And that's where scientific notation can really help us out. Instead of using a long sequence of decimal digits to represent numbers, scientific notation uses a shorter number multiplied by a power of 10. And it's always in that form, some number times 10 to the some exponent. Here's an example of a really long number, 125 million. And here's the equivalent number written in scientific notation, 1.25 times 10 to the 8th. Want to see how these two numbers are just different ways of writing the same thing? Let's start by making a copy of our big number and messing with its decimal point a bit. Where's the decimal point, you ask? Remember that it's always right here, immediately to the right of the ones place. We just don't need to show it if there aren't any decimal digits. Okay, so what would happen if we shift the decimal point one place to the left? Well, doing that would change the number, right? By definition, the decimal point is always immediately to the right of the ones place. So, shifting the decimal point shifts the ones place and all the other number places too. And if we line up the ones place of our new number with the ones place of the original number, you see that the new number is 10 times smaller. That means shifting the decimal point one place to the left is equivalent to dividing a number by 10. But do we want a number that's 10 times smaller than before? Well, no. We don't want to change the value of the number at all. We just want to write it in a different way. Since shifting the decimal resulted in a number that's 10 times smaller than before, to compensate and keep the value the same, we need to multiply the new number by 10. Making the number smaller and then compensating for that might seem like a weird thing to do, but it'll make more sense in a minute. Let's do that process again. Let's make a copy of the new number and shift the decimal point to the left again. Since that shifts all the number places, we can align the ones places and see that the same thing happened. The new number is 10 times smaller than before. So to keep it the same value as the original number, we need to compensate by making it 10 times bigger. We need to multiply by another 10. And if we repeat that process again, if we make another copy and shift the decimal point again, we'll see that the number gets 10 times smaller. So we need to compensate by multiplying by another 10. All right, time out. We seem to have a little problem here. Each time we shift the decimal point to the left, our number gets smaller, but since we have to compensate with a factor of 10 each time, it's making kind of a mess. This part's getting shorter, but this part's getting longer. No problem, exponents can fix that. Do you remember that exponents are a way of writing repeated multiplication? If you don't, then be sure to watch our videos about them before moving on. Instead of writing 10 times 10, we can write 10 to the second power. And instead of writing 10 times 10 times 10, we can write 10 to the third power. That's much better. Now we can continue on. We'll shift the decimal point again and multiply by 10 again. But this time, instead of writing another times 10, we can just increase the exponent by 1, since there would be a total of 4 10s being multiplied together. Let's keep going with this process of shifting the decimal point to the left and multiplying by 10 for each number place we shift. And we'll stop when there's only 1 digit remaining to the left of the decimal point. Wow, that's quite a pattern. Each time we shifted the decimal, the number got 10 times smaller. So each time we had to multiply by another 10 to keep the value the same. And because we did that, each one of these lines represents the same value. So even though it looks a lot different, this last line has the exact same value as the first one. In fact, it's just the original number written in scientific notation. But why is it only this last line and not any of the others? I mean, they all look pretty scientific to me. That's a good question. For a number to be in proper scientific notation, it's supposed to have only 1 digit to the left of the decimal. There can be more than 1 digit to the right of the decimal, depending on the accuracy of the number, but just 1 digit to the left. But why? I mean, that rule sounds kind of arbitrary. That's not arbitrary at all. If there's more than 1 digit to the left of the decimal point, that would mean that we didn't get out all of the factors of 10 that we could have. And factoring out all of the 10s helps us quickly determine a number's order of magnitude. Order of magnitude? What in the world is that? That sounds kind of scary. Order of magnitude is basically just how many 10s you need to multiply to get a certain number. And when a number is in scientific notation, the order of magnitude is just the exponent, because that's telling us how many 10s to multiply together. In this example, the scientific notation says that if we take this small decimal and multiply it by 8 10s, we'll get our original number. So scientific notation is a way of taking a really big number and reducing it down to a value that's less than 10, but keeping track of how many 10s we would need to multiply together to get the full number. You can think of it as basically just extracting its order of magnitude and storing it in exponent form. But why would we want to do that? I mean, it seems kind of complicated. Well,
Okay, I'm gonna stop right there. You guys are going to find out why on next week lesson. Because I probably took I probably went, I know I went past 30 minutes, but I'm going to stop it now because today I'm all over the place. I thought I had everything correct. I checked and it seemed like I didn't. So I apologize in advance, but I will be hopefully on track on Monday. Hopefully, it's just I don't know what happened today. I looked back on my notes today and it seemed correct, and then Andrew had to tell me that the numbers wasn't right, and then I check, and then it wasn't. So, and then my video, it's just you guys, technology. But I'm gonna stop rambling. So I'm through with my lesson. I will show you guys the rest of that video on Monday, and then you guys, I will show you 2 new problems of the scientific notation notes that you guys took today. I'm gonna give you guys some new problems with that. And then we will dive into multiplying and dividing scientific notation, and then also, if we have time, adding and subtracting scientific notation. So that will be on Monday's lesson there. So lots of things for Monday, lots of things for Monday, and hopefully it will go great for me, since Andrew is not gonna be here with me. Hopefully technology will work for me, but if not, I apologize in advance as of today's lesson. So I'm gonna stop rambling. I'm through with my lesson. So we are now going to enter into our um, mid-session break. I'm sorry, you guys. We are now going to enter into our mid-session break for 5 minutes, and then we will come back with Andrew's lesson. And then hopefully during the break, you guys, I'm gonna try to figure myself out because I'm just all over the place. So we're going to enter into our mid-session break for 5 minutes now. So mid-session break is starting now. All right, you guys. So we are now back from our mid-session break, and it is time for Mr. Andrew Frett lesson. So let's begin with your lesson. Hopefully, yours will go perfect, and not be like mine. So let's get started with your lesson, Andrew.
Yes. Sorry, I was eating a pretzel during the break, but so as many of y'all, to my sixth graders, how y'all doing? I know I missed a day. But I'm back. Today is my last day before my vacation. Since Damian used my joke earlier, don't fret, but I'll be back in like 2 weeks on Monday, October 26th. But on today, we're going to review operations with integers, and we're going to do fractions and decimals. So that way, kind of like get y'all prepared for what's to come. So let me share my screen real quick. First, we're going to do this one real quick. So, enlarge. So, on the first day, we talked about integers and absolute value, how a negative number is a number less than 0. Of course, everybody knows that. Positive is greater than 0. So 1, 2, 3, 4, 5. Is any number from the set -3, -2, -1, 0, 1, and 2, and 3. Opposites are the same distance from 0 to the number line. So you got -3 and 3. And I'll draw out a number line for you guys, for example, for my visual learners. -3 to the left, 3, +3 to the right. Okay, I did some examples. I know it's not on here, but I did some examples. Also talk about absolute value. So the absolute value of 4 is 4. If you put that negative in front, it will be the absolute value of -4. Okay, then we talked about that Monday. We talked about adding, subtracting integers. How if the sum is positive, if both integers are positive, and if it's negative, both integers are negative. But if the positive integer's absolute value is greater, then it's positive. But if the negative integer absolute value is greater, then it's negative. All right, so the first example we did 9 plus -5. So we did a draw 9, started at 9, went back -5, went back 5 spaces, and you get +4. So the sum is positive because why? The absolute value of 9 is 9. So 9 is greater than -5. And that's how I get a +4. So that's one example. Subtracting integers, to subtract, we have to add its additive inverse. So for this one, we did 4 minus 15, kind of rewrite it a little bit, 4 plus -15, and it's -11. Another one where you get -5 minus 8, rewrite it as -5 plus -8, and it's -13. Okay. And we did a problem where 4 minus -6, write it, kind of like add addition signs to it, and it's +10. And lastly, we did multiplying and dividing integers, and kind of did a part 1 of graphing 4 quadrants. So the product of two integers with a different sign is negative. So for existence, 2 times negative 6 is negative 12. But if we write it as negative 2 times negative 12, it is positive. So basically follow these rules here. The product of two integers with the different signs is negative. But if it has the same sign, it is positive. Dividing, it's kind of like the same thing as multiplying integers, excuse me. The quotient of two integers with different signs is negative. So you got negative 10 divided by 5, and it equals negative 2 because they have two different signs. Or what about same signs? Well, it's going to be positive. So negative 10 over negative 5 is 2. And then graphing for quadrants, how I told you that each one, if you're looking at a graph like this, you go clockwise. So you got 1, 2, 3, and 4. You will end up at the bottom right. Okay. Right. Let me stop share real quick. So that is your review of operations with integers. So I believe we are done. Let me see. Let me check. I believe we are done with operations with integers, and I think we are moving on. Yes, so we're done with operation with integers. Later on in the week, we are going to do a lesson rewind, which is brand new, where I will rewind to the lesson that I didn't get to, and I will actually talk about it. So today is going to be a fun part. Today is going to be fun because you know why? Because we're going to talk about fractions and decimals. Oh yeah, the moment I've been waiting for. So here are your notes for fractions and decimals. Make sure you get a paper, get a pencil or a pen, and take some notes. Please. Or if you have a phone, take a picture of it.
Yeah.
Full screen. Oh wait.
And while he is doing that, you guys, my 8th graders, I am so sorry with my lesson today. I was just all over the place. I really apologize. But on Monday, you guys, I will do this again. Because you guys were probably all over the place with my lesson. So it's like, what is he doing? Well, I got you guys covered on Monday, so I just had to say that I apologize in advance. That will not happen again. So. Continue on, Andrew. Sorry, just I had to say that to my 8th graders.
Okay. All right, so fraction decimals. First and foremost, if you didn't get what I said early in the week, where our lessons intertwine with each other, there you go. This is the part where our lessons intertwine, because during that first week that we did of our math virtual lesson, he talks about repeating decimals for like 4 weeks. Well, today he kind of like set up my lesson for that, because we're going to talk about fractions and decimals. All right. So some fractions like 1/2 and 3/4 can be written as a decimal. Now, remember that phrase that Damian has said many times? Can be written as a decimal, can be written as a fraction, okay? By making equivalent fractions with denominators of 10, 100, or 1,000. Now, sounds familiar, right? Now, if you pay attention to Damian's lesson about repeating decimals, or converting repeating decimals to fraction, you should already know what's up. You should already know, because he talked about it for what? For 4 weeks. 4 weeks. Okay. And there's two definitions that you should already know.
Yeah.
The decimal form of a rational number is called a what? Repeating decimal. Or if the repeating digit is 0, then the decimal is a terminating decimal. So those two definitions, the first 3 bulletins, y'all should already know.
Yep.
Automatically. But there is one thing that he did, there is one thing that he missed though, and we're going to talk about it. It's a bar notation. Okay? So while he talked about repeating decimals, 1.1212134568 whatever, or when it comes to repeating, so a bar notation is a bar line place of the digits that represents. Okay, so today it's gonna be a fun lesson. All right, so we got 2 problems here. We got 2 examples. We got 7/8 and 3/16. All right. So we are going to convert this to a what? To a decimal. All right. Now, I'm going to write this in red. Now, we're going to divide this, which is the fun part. We're going to divide this. All right. So we're going to do 8 divided by 7. All right. Of course, we're going to do long division. Yes. We're going to do long division. Okay. What times what equals 7? What times 8 equals 7? Nothing does. So we're going to put that 0 right there. We're going to add a 0 right here. What times what equals 70? Let me check. I do believe it is 60. Will be 8, which is 8 times 8 equals 64, if I'm not mistaken. If I am correct, then I know my multiplication tables, and it is. Okay, so it is going to be 8. Write this in green. So it's going to be 64. Okay, and that's going to give you 6. What times what? What times 8 equals 6? Nothing does. So I'm going to write that 0 right there. We're going to bring that down. And you're going to add that 0. What times 8 equals 60? Well, if I know my multiplication tables, I do believe it's going to be 7. So it's going to be 56. Okay, and it's going to give you 4. So what times 8 equals 4? Nothing does. So you're going to add that 0 right there. And you're going to bring it on down. You're going to add that 0 right there. Okay. And what times 8 equals 40? Well, if I'm not mistaken, I do believe it is 4. If I'm not mistaken. I could be wrong. But let me check. Actually, no.
5.
It is 5. Okay. So 8 times 5 equals 40. And ladies and gentlemen, we are done. Oh, wait, we're not done. Because why? Because we have to add a period. A decimal point, right? So, you know that little trick? So we're going to put a period here, and then we're going to move it over 1. We're going to carry that period right on top, and that is your answer. So 7/8 will equal 2.875. that is your answer. And that is an ugly circle. Let me try this again. 0.8. Okay, don't 7.
Oh yeah, don't you just
Okay.
love technology?
Okay, here we okay. 8, 7, 5. Okay, that is your answer. Okay. Now, if you have a calculator, can y'all see the calculator?
No,
Okay.
we cannot.
Oh, nope, y'all cannot see the calculator. Okay, let me stop share real quick. Let me put up the. Okay, you see this handy dandy calculator over here. So we're gonna go to mode. Oh, no. Sorry. You're gonna go to math actually. You're gonna do 1. You're gonna press number 1. And actually, hold on. All right, so you're gonna do. I remember this correctly. No, I don't want down. No.
Yeah.
Okay, here we go. I was like, I know. It has been. It's been a couple years since I used a calculator, so just bear with me. So we're gonna do 7 over 8. And then top that over there. So we want this into decimal form. So you'll be like, how in the world do we press that in our calculator? Okay, so you're gonna go to math. Okay, ooh, y'all can see it on the big screen. Okay, so and then you're gonna press number 1 right here. So, not 1, sorry. You're gonna go to math, then you're gonna press number 2, and you're gonna press enter. And then I don't know if y'all can see it on the big screen. Actually, I'm gonna move it over here. There you go. There's your answer. 0.875 to check your answer. Can y'all see that? That's either on that little computer. I mean, not computer, calculator screen, or not, or our screen.
Yes, we can.
So that's how you do it on a calculator. Okay. Now I'm gonna stop share real quick, and then we're gonna go to another lesson. I mean, not another lesson, another example. But this time it's a negative. Now, Mr. Frett, I thought we were just doing positives. Oh no, decibels can be negative too. It can be negative too. So, again, we're going to do this long division. So, up, here we go. So, what times 9 equals 7? I'm doing blue. Nothing does. So, I'm going to put a 0 right there. And then we're going to add a 0. Okay. What times 9 equals 70? Well, I don't know about you, but I do know 9 times 7 equals 63. So I'm gonna put a 7 right here. Oh, that's an ugly 7. Okay, and then I'm gonna write 63. Okay, and that's gonna give you what? A 7. Uh-oh. Okay, what times 9 equals 7? Nothing. So you're going to add a 0 and you're going to bring it on down. Okay. Again, what times 9 equals 7? Well, 70. Well, I kind of told you the answer right there. So it's going to be 7. Because why? Because I know my multiplication facts, my multiplication tables. It's going to be 7. Okay. And then you're going to add what times 9 equals 7? Nothing does. So you're going to add that 0. And you're going to bring it on down. Okay. And you're going to add a 0 right there. Again, it's going to be another 7. Okay. 9 times 7 equals 63. And it's going to be a 7. Now, I'm going to stop right here. Because why? Because you should already know what the answer is. You should already know. Because why? It's a repeating decimal. It's a repeating decimal. So I'm going to put RD right here. It's a repeating decimal. Because why? Because the answer is 0.777 and 7 and keeps on going. Now, this is the part where we're going to add that bar notation right here. We're going to add that line right above that 2 7s because why? It keeps on going. It keeps on going. But hold up, we ain't finished. We are not finished. That's not the answer. That's not the answer. Look right here. This is a negative, not a positive. It's a negative. So the answer is negative 0.7777777777777. This is your answer. Bring it back. This is your answer. Okay. Not 0.77 like this. That is not it. That's not the answer. Okay. Of course, you gotta add that period. Carry over 1. We'll put that right there. Carry on top. There you go. All right. Now, how to write this in a calculator. Let me see. I'm gonna go to math. I'm gonna go over here to fraction. You know. Then you're gonna press 1, and then it's you gotta go in front, and then you gotta put negative down here at the bottom. You're gonna go up, and it's 7/9. 7/9. You're gonna press that right button. Then you're gonna go math. You're gonna go down 1. Then you're gonna go to 2. Press enter. And there you go. See, it's negative 0.777777778. Okay. That's how you write. I know it's a lesson. I told you it's going to be fun and short, but that's how you write. Transform from a fraction to a decimal. Now, once I come back, we are going to continue with fractions and decimals. We are going to do We are going to do rational numbers and multiplying and dividing rational numbers. I mean, again. And then the week after that, we're going to do adding and subtracting like and unlike fractions. So be prepared for that. I know this is a short lesson. I know, but don't fret. We're just getting started. We're just getting started. Well, that is it for my lesson. I hope y'all take notes. I hope y'all learn something today. Of course, I'm going to review it over again once I come back in like 2 weeks. But yeah, that is it. I know it's a short lesson. I know it's like probably like a 10 or a 15-minute lesson. So I don't have any videos for y'all today, but don't you worry, there will be video for review day. So, but yeah, that is it.
All right. Great lesson there. Great lesson there. Repeating and terminating decimals, you guys. You guys should already know it.
I already know.
See, you guys, that's why we said at the beginning when we started this math session that our lessons, they're going to intertwine with each other. And you see, there you go right there. There you have it right there. So that's why we tell you guys to pay attention. 6th graders, you also pay attention to my lesson as well. My 8th graders, you also pay attention to Andrew's lesson as well. I know for the 8th graders, for Andrew's lesson, it's just a kind of like a recap, a refresh. And then to the 6th graders, this is what you guys will be learning and doing when you get into 8th grade. So that's why we tell you guys to pay attention to not only to one of our lessons, but to both of our lessons. Okay. That is why, because you see, as today, his lesson intertwined with mine's back in week 1. So pay attention to our lessons. Pay attention to our lessons, you guys. So great lesson, Andrew. Great lesson there. Absolutely enjoyed it. So now, that's the end of our math session. So again, you guys, thank you for tuning in with us. Thank you so much. We always upload, if you miss our session, we always upload snippets of it onto our Instagram accounts, the recap from the day's lesson that we talk about. And then we also upload our full version math session onto our YouTube channel the very next day. So on every Monday we come on here to record, it will be uploaded on Tuesday. And then on Friday when we come here to record, we upload it every Saturday. So make sure you have that down into your calendars to where you guys know each time that we do a math session, you know that it will be uploaded onto our YouTube channel. So again, thank you guys so much. And you guys know our motto is always the same time, same grind, but a different lesson.
Yeah, a different lesson.
Yes.
You already know.
Yes. So oh gosh, here I go again. I will see you. I do this all the time. I do this on here.
I'll do it for you. Damian, we'll see y'all on Monday for another brand new lesson of the math virtual session.
Yes.
Meanwhile, I will see y'all in 2 weeks, which is Monday, October 26th, with a brand new lesson. So without further ado, the way the video is going to point out, he's Damian Anderson.
Yes.
I'm Andrew Frett. We hope that you have a fantastic
day. Either you guys will probably watch this. Some of you guys will watch this tomorrow, which is Saturday. So I hope you have a fantastic Saturday, or whichever you watch this on, a Sunday, Monday, Tuesday, Wednesday, whatever. Have a great
day.
It is. Yes, whatever day it is. Yes, because we want you guys. Yes, we want you guys to have a. Yes. Yes. Don't Don't fret either. So you guys have a fantastic day, and I will see you guys next week for a new math session. So until then, you guys take care and wear your mask.
Maintain 6 feet.
Yes, and wash your hands. Wash your hand. Three. Okay, let me do this quickly. The three simple rules that you guys should do: maintain 6 feet distance, wash your
Wash your hands.
hands.
Wear a mask.
You
Take
guys,
care, everybody.
yeah,
Take
take care. Take care, you guys. See you guys next week.